Hello and welcome to this Lab 6 instruction video on chi-square and ANOVA. In this lab we'll go over how to use SPSS to create a chi-square or statistic, as well as how to use SPSS to create an ANOVA statistic. First thing we're going to do is open up GSS 2018 in our SPSS software, and we're going to go ahead and go to Analyze, Descriptive Statistics, Crosstabs. Going to select Display Variable Names, and we want to put Political View in the row. Again, we're going to be doing chi-square here, so we're going to move that to the row, and we're going to move Degree to the columns. Now generally when we put something into the columns, that's going to be our independent variable. So we are considering that something about the degree you have is going to impact your political views. Next we're going to go to Statistics. We're going to select chi-square so that we're going to calculate this chi-square statistic for this. Notice that we can select some Cramer's V, lambda, gamma, Kendall's tau b. We're not going to go and select those now, but know that they are options here. Next we're going to go to Cells, and we want to have the percent. So we're going to check the desired percentages. Right now, because we're using degree as our independent variable, we want to select column percent, and we'll hit continue. And then OK. And so here we have it. We have at the top here, we have our N, the valid percent, so the number of missing cases. And notice here we have that bivariate table. We have political views and then the highest degree completed. And so what we're displaying here are things like 8% of people with a less than high school degree are extremely liberal, 12.5% are liberal, 8.2% are slightly liberal, 41.4% are moderate, so on and so forth for each category of our independent variable here for highest degree completed. Down here we have our chi-square statistic. Our chi-square statistic is 84.775 with a degrees of freedom of 24, which leaves us with a 0.001 significance value. So that's going to be pretty significant. Alright, let's calculate an ANOVA now. So first thing we're going to do is we're going to go to Data. Because we want to limit the sample to females only, we're going to go to Data. We're going to click Select Cases down here at the bottom. Next, we're going to click If Condition is Satisfied. Again, I'm going to change this. So we have an if condition here. And in this if condition, we're going to put sex is equal to 2. So what that is saying is that if for the variable sex, it's categorized as 2, which again, if we remember, is female, then that's what we're going to use. So sex equal 2, we can do that either using your keyboard or you can click here. We're going to hit continue. And then OK. Now, what we have done is we have now limited our data set to only women, only females. Now, you'll want to make sure you don't save your data set this way, otherwise you'll have to re-download it, and we don't want to be using only women for the rest of our labs or for any other part of the lab other than this part. So make sure you don't save your data set at this point, or if you do, make sure you go down, re-download the new data set. Again, if at any point you're having problems with the lab assignment, I would go ahead and close everything out, re-download the data set, try it again, see if you messed up the data set somehow. So let's go on and conduct this ANOVA. Let's go to Analyze. We're going to go to Compare Means. We're going to do a one-way ANOVA. Here we go. and we're going to choose our dependent variable as age that our first kid was born. Notice that this is an interval or ratio level data. And then as the column or factor here, we're going to choose degree. And then we're going to hit OK. Well, we do want to, sorry, messed up a little bit. We want to go to options, got ahead of myself. We want to select descriptive. Now we can hit OK. And so here's our one-way ANOVA. We have some descriptives here, so it tells us what this would look like, the number in each category, the mean for each category of our dependent variable, which is age at which first kid was born. So for less than high school, their first kid was born at 20. If you had high school degree, they're born at 22. Junior college 24, bachelor's 26, graduate 27. You can see that as you have a higher level of education, the age at which your first kid is born seems to get later. And then down here we have our ANOVA. We have our between group sum of squares and our within group sum of squares, degrees of freedom, mean square between, and mean square within. And we have an F statistic of 57.20H, which is significant at a less than 0.001 level. So again, fairly significant. Alright, so that's all you need to know to complete lab number 6. Thank you very much. Good luck.